Hi everyone, in this video I'm talking about 9.6. This is our last section of this chunk of material. So the last section of chapter 9 that we're going to see before exam 4. So graph quadratic functions using properties. We've talked about parabolas a good amount up to this point. If you remember, we were launching those pumpkins and we were looking at the arc and figuring out how far the pumpkin was launched, at what horizontal location did the maximum occur, all those types of things. That was kind of a primer for this section. So I'm gonna actually bring our attention down here. So it says a quadratic function in this form. This form is called vertex form. It didn't really say that, I guess, anywhere here, but this is called vertex form. So every parabola has a vertex. Okay, so if you imagine this as some pumpkin being launched, this would be its vertex, the maximum height that occurred. So some x location and some y vertical. In this one, we would have a minimum occurring. So maybe this is like a graph of the temperature of some mountain town. This would be the lowest temperature of that town. So every parabola has a vertex. Vertex form allows us to identify what the vertex is. So if your equation is written in this form, then your vertex is literally at h comma k. So we take the opposite of what we see in here. So I get h, and we take exactly the same as what I get here. So let me just write this down again. So the vertex would be at this location hk. So we take the same, so same exact value. And for the x component of the vertex, we take the opposite. So this is the opposite. All right, so let's go on to page 130. So this one says, graph the quadratic function. We have negative x minus 1 all squared plus 4. It says state all the intercepts and give the equation of the axis of symmetry. So by the way, just to identify those things on this previous page, so this one would have an axis of symmetry across its vertex right here at x equals, it looks like 2. This one would have an axis of symmetry, it looks like right here at x equals negative 2. All the symmetry happens across that. Basically, this dotted line is acting like a mirror. The intercepts, so you would have an x-intercept right there and there on this one. You would have a y-intercept right here. So that's what's meant by intercepts. Over here, you would have x-intercepts here and here, and then a y-intercept right about there. So back to this one. So graph the quadratic function. This is written actually in vertex form. It says state all intercepts and give the equation of the axis of symmetry. So since we have negative x minus 1 all squared plus 4, this is vertex form. So I can immediately say that the vertex is, well, I take the opposite of this. So I'll have positive 1. And I take exactly what I have here. That's what I meant on this previous page by opposite and same. So I'm taking the opposite of what's in here for the vertex. I'm taking the exact same as what's out here. So here's opposite, negative 1 goes to 1, and then 4, I still have 4. So I know that the vertex is right here at 1, 4. There's that special point, the vertex. All right, so as far as the intercepts go, what I'm going to do now is actually just create a table of values. So here's what I recommend doing. This will be x, this will be f of x. What I'm going to do is place the vertex right in the middle. And then what I'll do is I'll pick 2 points below it and 2 points above it. So 0, -1, and then 2 and 3. And now I'll plug -1 into the function and see what we get. So now I'm taking -1, this value, and plugging it into the function to see what the output is there. I'm basically using the point plotting method. If you remember that, that works here too. So plugging in a -1, I have -1, -1, I need to square and then add 4. So that is a 0, actually. So for -1, I get 0. Let's see what we get for 0. So I'll replace -1 with 0, press equals. I get a 3. And then let's go down here. I'll plug in a 2. I get 3. And then let's plug in a 3 to do this last one. So I actually get a 0. So if you check this out, we got 0 here, and I got 0 there. I got a 3 there, and I got a 3 there. And that actually is no accident. That's because the symmetry is taking effect. So let me plot these points. I have 0, 3, right? That's that point. I have 1, 4, that's this point. I have 2, 3. And then I have 3, 0. And then I guess I didn't plot -1, 0. So here are 5 points. I'll actually draw the parabola at this point. And then check out what we accidentally found. So this would be an x-intercept, right? Remember, whenever y is 0, you're finding an x-intercept. This is also an x-intercept. And this right here, since there's a 0 for x, this is a y-intercept. So we just so happen to accidentally find all the intercepts. So maybe over here, I'll actually state them explicitly. So for x-intercept, right, that was a part of this problem, state all the intercepts. We have -1, 0, and we also have 3, 0. For the y-intercept, there's only one. I have right here 0, 3. So graph the quadratic function. Here's the graph. Here's the intercepts that we were being asked for. And then it says, give the equation of the axis of symmetry. The axis of symmetry always goes vertically right through the vertex. And since it's passing through 1 right here, this is x equals 1. And I'll just say AOS for the axis of symmetry. Okay, I'm leaving example 2 open. Of course, I'll post a solution to that one alongside the video. So going on to page 131. Not every equation that you're going to see is already in vertex form, right? So what if you're given an equation that's in standard form? How can you find the vertex? You can find the vertex this way. All right, so for an equation given in standard form, the vertex would be located at opposite of b over 2a, right? This is the b I'm talking about, this is the a I'm talking about, and then f of opposite of b over 2a. So that's what this formula is telling us. So example 3, here's our equation, and we're just asked to find the vertex. So we have A is 2 and B is 8. So the vertex of this particular one would be at opposite of 8 over 2 times 2, right? Opposite of b over 2 times a. And then f of that. And I need to simplify all this, of course. So in other words, we have negative 8 over 4, that's negative 2. And then I need to figure out what f of negative 2 is, right? This is also negative 2. So plug in, so I have 2 times negative 2, and then I'm squaring, right? I'm taking negative 2, and I'm plugging that into the function to see what the y component of the vertex is. Right, so 2 times negative 2 squared plus 8 times negative 2 minus 1. This is equal to negative 9, it looks like. So the vertex of this one would be at negative 2, negative 9. So what if we want to graph when we're only given the standard form? So this says graph the quadratic function, including its intercepts and axis of symmetry. Use the graph to identify the function's domain and range. So I'll start with the vertex part. That's kind of a nice point to start with. I have, in this case, a of negative 1 and a b of 4. So the vertex will be at the opposite of b over 2 times a, and then f of the opposite of b over 2 times a. So in other words, simplifying this, we get negative 4 over negative 2 is 2. And then I need to find f of 2. This is all just for the vertex part. So now I'm plugging in 2 into this function that we were given. So negative 2 squared plus 4 times 2 plus 1. That's 5. So 2 comma 5, that's our vertex for this particular one. So I'll plot that. Here's 2 and 5. And now I'll do the similar thing that I did before, is I'll use the point plotting method to get some more points. So this will be x, this will be f of x. So I'll plot the vertex right in the middle. And then I'm going to pick 2 below. 0. And then 2 above. Based on the symmetry, I know that this output is going to be exactly the same as this output, and this output will be exactly the same as this output. So I can kind of get away with half the work. So plugging in a 0 here, all these drop away and I just get 1. So I know a 1 goes there and there based on the symmetry. Plug in a 1. So negative 1 squared. Sorry, so I'm plugging in a 1 here. So plus 4 times 1 plus 1. So I get a 4. So I know that a 4 goes here and here based on the symmetry. All right, so we have 0, 1. I have 1, 4. Here's my vertex already. 3, 4. And 4, 1. So this is the parabola. And it looks like we accidentally found the y-intercept. What color? It was blue. So right here, we accidentally, just through doing the point plotting method, we accidentally found the y-intercept. So I still need to find x-intercepts. It looks like this particular one will have x-intercepts. It looks like right about here and here. So I still need to find those. How do we find x-intercepts? we let f of x equal 0 and solve for x. So I'll have 0 equals negative x squared plus 4x plus 1. So I can use a is negative 1, b is 4, and c is 1. I can use the quadratic formula, in other words. So x will be equal to opposite of b, plus and minus the square root of b squared, minus 4 times negative 1 times 1, all over 2 times negative 1. All right, so let's type that in. Okay, so fraction negative 4 plus square root 4 squared minus 4 times negative 1 times 1 over 2 times negative 1. So I have an x-intercept of 2 minus root 5. I'm going to leave that in exact form, but just to make sense out of it, it's about negative 1/4, which makes sense with this location. But really, I'm going to leave it this way. So let's write the intercepts. I have 2 minus root 5, that's the x component, and then a 0. If I change it to the minus case, then I get 2 plus root 5. So my x-intercepts are 2 minus root 5 and 2 plus root 5. And then maybe just right here, I'll state the y-intercept explicitly. So 0, 1. So those are a couple of things we wanted. So it said including intercepts, axis of symmetry. So the axis of symmetry in this case, it's going vertically through 2. So axis of symmetry, x equals 2. And then it also says identify the function's domain and range. So for domain is a list of all the allowed inputs. This is a polynomial. We're allowed to plug in any number we want. So the domain is simply every real number, negative infinity to positive infinity. The range, you can see it here, the largest output achieved is 5, and then everything below 5 is achievable. So the range would be negative infinity up to and including 5. All right, so I'm going on to page 132. So here's some information about minimum and maximum values. You can learn things just right up front, even from this function. So based on this value, so that 4 right there, 4 is greater than 0, which means we're in this a greater than 0 case, which means that this thing is opening up, and therefore there will be a minimum associated with the vertex. Right? If we had a different parabola, and this were a negative 4, for instance, then we would have a parabola that's opening down, and we would have the vertex associated with some maximum point. So since A is positive, I know this thing is opening up, so opens up, and therefore I'll have a minimum value. So part 1 says determine without graphing whether the function has a minimum or a maximum value. So for part 1, f has a minimum because a equals 4, which is greater than 0. Oops, sorry about that. So f has a minimum because a equals 4, which is greater than 0. And that falls into this case. Part 2 says find the minimum or maximum value and determine where it occurs. So we have a minimum value. So we're going to find the minimum and figure out where it occurs. In other words, where the x is. So this is in standard form. So I have, like I said here, we have a equals 4 and b equals negative 16. So for a vertex calculation, which is really what part 2 is about, the vertex will be at opposite of negative 16. So in other words, 16 over 2 times 4, and then f of 16 over 2 times 4. Simplifying, we have 16 over 8. So we get a 2. It won't always be 2. I'm kind of realizing now that we had a lot of 2's for our vertex, but it won't always be that way. And then we need to find f of 2. So plugging in a 2 into the function to figure out the y component of the vertex, right? So 4 times 2 squared minus 16 times 2 plus 1,000. So 984. So the vertex would be 2, 984. So the minimum value is this 984. So min of 984 at x equals 2. So this one said find the minimum. It's not a maximum in this case. And determine where it occurs. So the minimum is the output. And this is the location at which that minimum occurs. Part 3, find the function's domain and range. Since this again is a polynomial, any number can be plugged into here. So the domain will again be negative infinity to positive infinity. And the range, well, the lowest value achieved, which we just saw from the previous work, is this 984. So the minimum value achieved is this. So we're going to go up from there, since it's opening up. So 984, comma, infinity. So this would be the domain and range. Okay. So I'm leaving the next one open. Of course, I'll attach a key. But let's go on to example 7. It says, find the quadratic function that fits these points. All right, so just to sketch a quick picture, if this is 0, 6, maybe this is 1, 8, maybe this is 3, 4, we're looking for the parabola that contains all these points. All right, that's what we're doing here. We want to find the quadratic function that fits all these points here. So we're looking for an f of x, which equals a x squared plus bx plus c. And we're basically wondering a, b, and c. As soon as we know a, b, and c, we know the function. So we know that we have an output of 6 when the input is 0. So I can write 6 equals a times 0 squared plus b times 0 plus c. For the second point, I know I have an output of 8 when our input is 1. So a times 1 squared plus b times 1 plus c. And then for the third point, I know I have an output of 4 when the input is 3. Okay, so this system would, in other words, simplify to 6 equals c, right? Everything goes away except c. 8 equals a plus B plus C, right? And then 4 equals 9A plus 3B plus C. So I know that C equals 6, so I can just replace C with 6 here and there. So our system can be rewritten as 8 equals A plus B plus 6, and 4 equals 9A plus 3B plus 6. All right, so simplifying, I'll subtract 6 in both cases from both sides. So I have 2 equals A plus B, and I have negative 2 equals 9A plus 3B. So I have this system of two unknowns, A and B. So you can use elimination, substitution, a matrix if you're feeling fancy. So what I'll do is use substitution. So in other words, 2 minus B, if I subtract B from both sides, would equal A. So I can take 2 minus B and replace A with it. So negative 2 equals 9 times 2 minus B plus 3B. And now I have one equation just involving B that I can go ahead and solve. All right, so distributing, we have 18 minus 9B plus 3B. Solving for B, I'll subtract 18. So negative 20 equals, looks like negative 9B plus 3B, that's negative 6B. And then divide by negative 6. So in other words, B, 20 over 6, is 10/3. And that's how I'll leave it, just so we know that's exactly equal to 3.3 forever. So we just found what B is. A is 2 minus B. So A would be 2 minus 10/3. So 2 minus answer, negative 4/3. Which is about negative 1.3333 forever. So we have found the function. In a second, I'll go to Desmos and show you another way of doing this. So the function would be negative 4/3 x squared, b, so plus 10/3 x, and then c we know is 6, so plus 6. So this must be that function. So what I'll do now is go over to the computer. Hopefully you can see it, and I'll show you how to use Desmos to verify this and also find this. So bear with me for a second. Okay. All right, so hopefully you can see that. I'm going to go to Desmos. Let me get my wire from under there. Scoot that up a little bit. Okay. All right, so Desmos, let's go there. And what I'll do as a check is I'll type in the original points. So we had 0, 6, and then we had 1, 8. And then we had 3, 4. If you click over here, this little magnifying glass, it'll kind of nicely find the data. I'll just make that more. So here they are, those 3 points, kind of like the picture I drew earlier. So if I type in the function that we just found, we should see that it goes through these 3 points, and it would be the only equation that does that. So if I go y equals, I'll just use, maybe I'll use f of x. I don't think maybe it'll dislike that. We'll see. So negative 4/3 x squared plus 10/3 x plus 6. We should see that that function populates exactly through those points we had. So indeed, this function is doing the job that we were hoping it was going to do. So if you want, like, let's turn this off, and let's say we just have the data there, and we just want to find the function with Desmos. So not even worrying about doing all the math that I just did on this page. So what you can do is reference this data table. So what I'll say is y1, and then you want to find this button, so this button here, and you want that little wavy symbol. So I'll go shift that button, and that little wavy symbol pops up. And what I'm going to do is write a x1 squared. So what that's doing is it's referencing this part of the data, x1. So it's not doing a very good job, right? This red line is not going through any of the points. So I'm going to add more terms. So b x1. So it looks like it's going through 2 of the points now, but this one is left out. So what I'll do is say add a constant c. And then as soon as I do that, that function is found. What it's saying over here is what these values are, right? Negative 1.333, that is exactly what we found here. Negative 4/3 is negative 1.333 forever. B for an exact form is 10/3. Desmos is just doing the best job it can, so it's saying it's 3.333 forever, but that's exactly what 10/3 is. And then it found C to be 6. Which is exactly what we had for C. Okay, so you have the option of doing this type of problem. If you're looking for a function that fits data, you can use this format here. All right, talk to you next time.